Hello everyone, in this video we'll learn about converting an Infix expression like into postfix notation. Infix notation has operators between the numbers, while postfix moves operators to the end, making it easier to evaluate without parentheses. By the end, we'll also see how to evaluate our final postfix expression. Before starting the conversion, the code checks if the parentheses are balanced. If there's a missing or extra parenthesis, it throws an error. This is crucial because unbalanced expressions are invalid. This check prevents issues later in the conversion. Now let's go through each character in the Infix expression. The code goes character by character to decide what to do. Here, if the character is a digit like 1 or 0 or a decimal point that hasn't already been used in number 10 is add to number 10. This allows us to handle multi-digit numbers like 10. If the character isn't a number, it means the current number is complete. So we add number 10 to the result, followed by a comma and reset number 10 to prepare for the next number. Next, parentheses control the order of operation, and the code handles them with these lines. When we see an opening parenthesis, we push it onto the stack. When we find a closing parenthesis, we put all operators from the stack until we reach the opening parenthesis. This manages expressions like by making search everything inside. Parenthesis is processed first. When we encounter an operator, we need to check its precedence. This part of code uses a function called precedencia. Operators like multiply and divide have higher precedence than plus and minus, so they stay in the stack longer. This part of the code ensures that higher precedence operators are processed for lower precedence ones. So for we'll handle plus first, then multiply. Once we reach the end of the expression, we're almost done. The code empties the stack to add any remaining operators to the postfix result. Here's that part. After processing all characters in, any operators left in the stack are added to our postfix expression. This gives us the final postfix result, which is here's the full conversion of our expression. We handle numbers directly. We push and put operators based on their precedence. Parentheses control what we process first. By the end, the expression becomes in postfix notation. This new format makes evaluation easier. Now that we have our postfix expression, let's evaluate it using this part of the code. The code goes through each element in the postfix expression. If it's a number, it pushes on the stack. If it's an operator, it puts the last two numbers, performs the operation, and pushes the result back onto the stack. Let's go through the postfix expression step by step, using a stack to evaluate it. Here's how we handle each element in the expression. 10. It's a number, so we push 10 onto the stack. 2. It's also a number, so we push 2 onto the stack. Plus. We've reached an operator plus, which means we need to perform an operation. We pop the last two numbers from the stack, 2 and 10. Then we calculate 10 plus 2 equals 12, and push the result back onto the stack. 3. It's a number, so we push 3 onto the stack. Multiply. We have an operator, multiply, so we pop the last two numbers from the stack, 3 and 12. We calculate 12 multiply 3 equals 36 and push the result back onto the stack. 8. It's a number, so we push 8 onto the stack. 4. It's a number, so we push 4 onto the stack. 1. It's a number, so we push 1 onto the stack. Minus. We encounter the operator minus. We pop the last two numbers from the stack, 1 and 4. We calculate 4 minus 1 equals 3 and push the result back onto the stack. Divide. We had an operator divide, so we put the last two numbers from the stack, 3 and 8. We calculate 8 divide 3, which is approximately 2.67, and push the result back onto the stack. Minus. Finally, we encounter the operator minus. We pop the last two numbers from the stack, 2.67 and 36. We calculate 36 minus 2.67, which is approximately 33.33, and push the final result onto the stack. Final result. At the end, the only number left in the stack is 33.33, which is the result of evaluating. To wrap up, we've learned how to convert an Infix expression into Postfix and then evaluate it. The stat helps handle operators and parentheses efficiently, making complex calculation easier. This technique is essential for understanding how expressions are processed in programming and computational math. Thank you for watching.